All right, in this video we were just going to talk about calculating sector area. This is the last new section that we'll be covering in the year that actually you'll see on your mid-quarter exam next week before we start our end-of-year review. So we'll make it through this one talking about sector area, and then your second assignment this week is going to be application problems related to sector area and arc length. And then we will begin to review for our mid-quarter exam. So let's talk about sector area. Again, if you practice with the arc length, this is going to feel very similar. So our learning target, students will be able to calculate, right, the area of a given sector of a circle. So let's talk about what a sector is. Now recall the arc length was a fraction of the circumference. So arc length, right, is a piece of the outside of our circle. Area is the inside. So we practiced a little bit with area, right? So when we talk about sector area, we're talking about a region on the inside of the circle. For example, if I have a little circle here, the arc length of this piece is just the length on the outside, but the sector area is the length of a certain fraction of the area. So whether it's a fourth of this area of the circle or half of it, you're just looking at a fraction of it. And again, just to kind of relate it to maybe something that we all relate to, pizza. Arc length is like the length of the crust along the outside. Sector area is if you were finding the area of the whole piece of pizza that you were going to order. Okay, it's the whole thing on the inside and we're finding the area there. So let's just review the formulas. That's really the takeaway that you need from the notes today. The first one is degrees. So we talked about your angle can be in degrees, and if you want to find the arc length, that was a fraction of the circumference, right? So to find the arc length, we really just took the circumference and then we times it by whatever our angle was divided by 360 because that gave us that fraction. Now circumference, you can use whatever formula, so I believe we also wrote this as 2 pi r over 360. Again, that's the same thing. We just wrote it out as the circumference, so you can write it either way. Okay. Now, when we find the sector area today, it's essentially the same idea, but instead of using the circumference formula, you're using the area formula. So again, we're doing the area times the fraction. Okay, so essentially it's still the theta over 360. And again, remember area is pi r squared. So you have pi r squared times theta over 360 degrees. Okay, either of those you can use to solve. Now, if we're in radians, again, if we wanted to find arc length in radians, that relates directly to the radius. So you just took whatever your angle was and you just times it by r. That's all we had to do. The sector area, when it's in radians, again, also related to squared units, so this is actually going to be 1/2 theta times r squared. Okay, so this is kind of the 4-in-1. Again, making sure that you have all of those formulas written down, and then it's just a matter of identifying. You guys are going to be allowed to use your notes on your test. So if you have all of these formulas, then we should be able to just plug them in. Number 6. Let's look at some ways to use the formula. Determine the area. Again, make sure you know if it's area or arc length of the bolded sector. Round to the nearest tenths. Now on your assignment today, you're going to be asked to state whether it's in degrees or radians. So the first thing you want to do is you want to look at the angle. Now, this angle right here, right, it says is 3 pi over 2. 3 pi over 2 is definitely radians. So I know that I'm finding area and that I'm in radians. So I come up here and I'm going to say, okay, area and radians, I'm going to be using this formula right here. Okay, so again, I'm going to write it right here. Sector area is going to, I'm going to write SA, it should be 1/2 theta r squared. So if I want to find the sector area, I'm going to do 1/2. I'm going to times it by theta, and in this case, again, theta is your angle, so 3 pi over 2 times 13. Now, if you're putting that in your calculator, just make sure you put parentheses around things, and as long as you are taking care of those parentheses, then we should be able to calculate and identify the arc length there, okay? And we're just going to approximate that to the nearest tenth. So we should get 398.2 it didn't tell us what the units. Oh yes, it did, yards. 0.2 yards squared. Okay. Again, looking at number 7, determine the area of each sector. So we're going to find the blue and the orange looking sector. Again, maybe let's do the orange first. Notice this time, if I'm looking at this angle, this is in degrees. So this 120 degrees, I'm going to use that angle to find this sector over here. So again, if I'm in degrees and I'm finding area, I'm using this formula up here. So all we're going to do is we're going to say, okay, well, the sector area is equal to, right, pi r squared. R in this case is your radius length. So my radius is 14 squared, and then we times it by the fraction of the circle we want to find. And our angle measure is 120, and then we put that over 360. Okay, again, you're just going to plug that whole thing into your calculator, and you should get about 205.3 square feet. Okay, now that one's for the orange sector. It asks us to find both. So what would the other one be? If we think about it, right, the radius didn't change at all, so it's still pi r squared, and it's still out of 360, but we need to figure out what this angle for the blue section would be. So remember, a circle is 360 degrees, so if this piece over here is 120, then we take 360 and we minus 120. So again, you just take 360 minus 120, and that gives us 240 degrees. So we know that the blue section is really big. It's about 240 degrees. So then we calculate this. And again, you're just doing 196, right? Or sorry, 14 squared times pi. Once you get that, you multiply it by that fraction, and we should end up with 410.5 feet squared for the blue section. Okay. Again, just picking out the formula and then make sure we're applying that correctly. On the last one, it says determine the area of circle H. Now this one wants us to find the area, and it gives us an arc length. So you'll notice it's labeling this piece right over here, and it's saying that that is 214.37. So this is one of those where we are given we want to find area, and we're given a piece of the sector area. So we are going to look up here, and we're going to say, okay, well, 85 is in degrees, so I'm going to use this degree one, okay? And we're going to say, well, sector area is equal to the area of the circle times theta over 360. That's our formula. So they gave us this sector area of 214.37, and that's equal to the area, which we don't know, and we're going to find. And then we have 85 as our angle there on the inside over 360. Now the question is, how do I solve for A? Well, A times this, right, is equal to that. So if you just want to divide by that, and you guys can just do it all at once if you want. That'll get rid of that guy. Divide by 85 over 360. That leaves you with the area. So in this case, your area is approximately 907.9. And again, we're looking at centimeters squared in this case. So just like arc length, the formula is very similar. You're just going to practice going through that. Again, practice with this one so that when we do the application problems, you're able to apply these.